Here we have a nice example of a related rates problem. We have an expanding cube in which the edges of the cube increase at a rate of 2 centimeters per second. How fast is the volume changing when the length of each edge is 50 centimeters? Okay, well there's a step-by-step process to approach these kinds of examples. We can switch back and forth between the steps and the example itself. Step 1 says to read and reread the problem to gain an intuitive understanding. Sketch a diagram if possible, identify the rates that are given and the rate that is to be determined. So step 1 basically asks, do we understand what's happening? Well, can you imagine a cube that's getting bigger and bigger and bigger, an expanding cube, right? It's expanding at a rate of 2 centimeters per second. And it also asks us to draw a picture, and that's crucial for related rate questions. You always want to sketch a diagram. So let's see. Just something simple so you have an idea of what's happening, right? It helps the mind intuit what's going on. So here's a cube, right? Excuse my drawing here, but it doesn't have to be perfect. X, X, and X, right? It's a cube, so clearly this is not to scale. And given and goal. That's a good way to keep track of what we have and what we need. So what are we given here? We are given that the edge increases at a rate of 2 centimeters per second. So that's dx dt equals 2 centimeters per second. Our goal, it's asking how fast is the volume changing. So our goal here will be dv dt. And it actually wants it at a certain time when x is 50 centimeters. So we're off to a good start with this related rates question. We have a diagram, hugely important. We have listed our givens, just one in this case, and our goal. On to step 2, write an equation that relates the various quantities of the exercise, and if necessary, use geometry to eliminate a variable. Okay, so we have our given and our goal. Let's come up with an equation that relates both of them. How about this? V equals x cubed. You need to know a little bit of geometry to do these equations, but that's the volume of a cube, side times side times side. So there we have related the two variables. Step 3, use the chain rule to differentiate both sides with respect to t. Okay, so I'm going to take d by dt of both sides. D by dt of v equals d dt of x cubed. And what this gives us is, well, the left side is simply dv dt. Okay, equals, on the right we have 3x squared, there's the power rule, times dx dt. That is the chain rule, because note we're taking the derivative with respect to t, not with respect to x. And there we have related the two rates, thus the name of these kinds of exercises, related rates. Step 4, substitute known values and solve for the desired quantity. So what we have so far is a very general equation for dv dt. What we want is our goal here. We want to know how fast is the volume changing when x is 50 centimeters. And here's an important point. Wait until you've done your differentiation to plug in for the variables. One of the biggest mistakes you see on this kind of example is people plug in for x right at the beginning, and then when they go to take their derivative, it's just a constant and it goes to 0, and things get really pointless really quick. In our case, we have taken the derivative, so now we can plug in. Let's go over here to the left. We have dv dt evaluated at x equals 50. I'm just going to stop writing the units. Okay, that is 3 times 50 squared times dx dt. Well, we know that dx dt is 2 centimeters per second. If we compute that out, we get 15,000. And then our units would be volume per time. You could look at dv dt, units of volume, centimeters cubed per time, second in this case. So notice that that relatively small change in x gives an enormous change in volume when x equals 50. If you can imagine the changes when x is very small, the volume would also be very small and changing very slowly. The bigger x gets, the more extreme of an effect it has on the volume, because the volume is changing by a factor of x squared. So around x equals 1, not much happening. Around x equals 50, a whole lot happening.